You're just lying, so when you get a good grade, you'll look smarter. I didn't even study this, guys. I'm failing horribly against this.
I did say at some point I was going to quiz you on what is the be able to write the whole Greek alphabet, but I don't know if I can write the whole Greek alphabet. I can.
You know Baker.
I can say the whole Greek alphabet. I can't write it necessarily. I can probably make a pretty good guess at some of the symbols.
I'll make a guess. The letters might come to form some unconstrained words in English.
All right. So we want to go back to our source reader. What's up? So remember last time we were talking about statements. We actually looked at some code for processing statements, but we want to start dealing with our look-aheads. Okay, so we want to start thinking about look-aheads. So what we're going to do is we're going to create our token stream, which we're already doing, right? Then, as we walk through our token stream, we want to identify the type of statement we're looking at. And based on the type of statement we're looking at, because we're dealing with a statement-based language, correct? We decided Java is a statement-based language where it's at least one statement containing other statements. So we want to identify what we just read in, and if it's the beginning of a statement, we want to know what to expect so that we can go and start matching things after that. Okay, so we're going to go back and kind of reinvent some of our compiler so that during step 2, we can actually do some syntax checking. All right, so let's go back to the code. Don't play games in here.
All right, I'm going to start after class.
Or we will have quizzes.
I hate quizzes.
Let's see, what was I doing here? Driver. Okay, so right now inside of our Lexical Analyzer, we are probably calling our thing to create our tokens. So let's go look at our Lexical Analyzer. Okay, so right now, if we look at our Lexical Analyzer, we're actually kind of solving two problems in one. The first problem we're solving is we're reading in a token, but rather than storing that token, we're actually lexically analyzing it right off the bat. Should we be doing that given what is happening? Given the way these trees are being constructed in here. We get down, here's our grammar for a statement. I think it's repeated down below. But here's our grammar for a statement. And then we have some examples for our look-ahead trees. Oh, we'll use the simpler grammar for this one. Okay, yeah, so let's assume we have this simpler grammar for our statement. So for our tree, we are grabbing this is a token, this is a token, this is a token, this is a token, this is a token. Are we lexically analyzing these guys or not? So the question is, if these are all my tokens, have these been lexically analyzed? Why or why not?
Well, I'm not paying a lot of attention to you, but it seems like this is coming after the lexical analyze step, so it seems like it would have been, because this is being read from
Okay,
the stream,
what does the lexical analyze step do?
I think that was the one that put them into a stream of tokens or whatever, so went through them all, it was like, oh, this is one of these, and then it stuck it in the little thing.
Okay, so it wrapped all of our textual tokens into a package that helped us identify it. Okay, so if we are collecting these tokens, the question is would these be evidences of what should come out of the lexical analyzer? Or have these not been lexically analyzed? And how do you know? Keeping in mind, we're dealing with a more, a very different kind of language here than we were with our, when we had our example working with our lexical analyzer. So you can't necessarily look at one-to-one comparisons, but you need to think about what the lexical analyzer accomplished. So if we think back to that, our lexical analyzer identified what? Identifiers, as well as their position in the symbol table. That's what it wrapped. Literals and operators. Right? Okay. So are these things, are these already lexically analyzed? Go ahead.
I want to say yes, but I'm not sure my answer is going to be sufficient.
Was that the end of your answer, or do you have explanation?
That was it.
Okay, because if that's the end of your answer, it's not sufficient enough. But if you have some explanation, I'd like to hear it.
Well, to me, it looks like it's been separated enough where we could go into the next stage and put it into a tree.
It's definitely been tokenized.
Yeah.
So we've definitely split it into individual tokens, but has it been lexically analyzed? Has each of those tokens passed through the filter where we've wrapped the ones that make sense to be wrapped and not wrapped the ones that don't make sense to be wrapped? Which? Two.
Those all say opt expression. That's a statement instead of like actual values. So it feels like that's evidence that they've been analyzed lexically.
Yep. So they have been analyzed because part of what we read is something that should be an opt expression. And we're going to have to dive into this further and process an opt expression. Correct? Okay. So the question is this is the syntax for a for statement. For, open parenthesis, opt expression, semicolon, opt expression, semicolon, opt expression, closing parenthesis, followed by a statement. What is this example of? What is this an example of? Okay, it's what a statement is, but are we actually looking at tokens? Or are we looking at our look-ahead expectations? Okay, so none of this has been lexically analyzed. Why? Because they're not our real tokens.
They're just what's expected.
It's what's expected. When would we create this type of expectation? At what point would we come to this conclusion? As soon as we see the 4. So when we are walking through our tokens and we see a 4, we know, well, in our particular case here, since our language is very small, we know that the only thing that starts with the word 4 is a statement that looks like this. So you better have the rest of these parts or you're wrong. And, and we will yell at you, correct? What's the purpose of lexically analyzing our code?
Fix human error.
We're going back to the very first step. So certainly checking syntax. Syntax, to analyze the syntax is certainly to fix our errors. But why are we wrapping tokens inside of these packages after we lexically analyze them? What's the purpose of that? Think back to last semester. We used a similar word, lexical, right? We wrote a little function and scheme called lexical address. What was the purpose of that?
Deal with scopes.
Yeah, the lexical address really has a lot to do with scoping. So when we lexically analyze code, we are mostly thinking about placeholders for variables and scoping for variables. Right now, we're not really dealing with the multiple layers of scoping. We just kind of put everything into a single symbol table and just assume that it's this giant linear table and everything exists in one gigantic scope. But that's the purpose of lexically analyzing our code, is to deal with variables and deal with scopes. All right. Is this guy a variable? this guy a variable? Is this guy a variable? He might hold some variables possibly, but him in and of itself is not a variable. Not a variable, 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 not a variable. Let's look at our statement grammar. Are variables even represented in our statement grammar? Kind of where? The other just kind of captures everything, right? Like technically everything is technically part of our statement.
That's a wrap.
Okay, so we don't actually have a specific syntax for variables in our statements. Should there be? Well, how do we define variables in Java? What's the syntax for defining a variable in Java?
Type, name, like placeholder,
Assignment.
Is this our quiz? Variable type, because it's a strongly typed language. Variable name, has to match some certain rules, but variable name. Optionally equals a value, semicolon. Right? You can define a variable without giving it a value, but every single variable definition will have a type, a name, and a semicolon. And then optionally an equal value between the semicolon and the name. All right? Does this language up here support that? How do you know? Is that a statement or is that an expression? So down here we have this magical expression guy. So is our let me go back to Keynote here. What? Man, look at this crap we're doing in Game Salad. No, this is 200.
I think Paul almost killed me. That's so funny.
What class is this?
450.
I have like cowboys on all the default images.
What's up?
Alright.
All right. So variable syntax in Java is type, name, optionally equals, val, followed by semicolon. Right? Okay, so some examples of this are int a is equal to 5, int b, semicolon. Those are both variable definitions, correct?
Like a B, comma, A, comma, C.
Like that. It's kind of a special syntax. You don't want that. Unless you want that for your homework in here.
Never mind.
All right. So, are these statements or these expressions?
Expression.
In Java, what distinguishes a statement from an expression?
Statements end with semicolon.
Statements end in semicolons or,
Curly.
well, so here's our statements. We have an expression followed by a semicolon. We have an if, which doesn't have a semicolon in it, but that's the structure. So this is an example of a statement. This is an example of a statement. This is an example of a statement for whatever other stands for. Just forget others even exist for right now. Okay? So where do semicolons exist? Semicolons exist in an expression statement. That makes sense? So we can say that any statement, any line that ends in a semicolon likely is a statement. Okay? Does that make sense? So if we come back here, we can say with confidence that these guys are statements. We can also then say with confidence that these guys are not represented in our current language. Correct?
Yeah.
Unless they're
Other.
other or they're dealt with in expression. Okay? So expression might have a type expression or type def expression where we might say int a equals a value. But it's a statement because it has a semicolon at the end of it. But at the very least, it doesn't appear at this level that it exists in our language. Okay, so Beaker was saying that as soon as we run into the for, that at that point, because of what our statements look like, remember, our parser is parsing statements, correct? Our program is a collection of statements. So each statement is in and of itself something that we parse. So we're going to try to parse the entire code as a statement. Why? Because our entire program is a statement. And inside that statement, we have other statements. Remember last time we were looking at the recursive definition of matching statements? Yeah. Okay? So everything is a statement. So we're going to be matching statements. And as soon as we match something that starts with a for, as soon as we see a for, we know that the...
He's excited about that.
What was that?
This is my aunt's computer and it's kind of broken, so I'm trying to fix it. And I'm running the test.
What computer makes that sound? Like, what was that sound?
It's the diagnostic.
Oh. Skippy should have been going off. He should have been like, excuse me.
The phlegm is just killing.
Some questionable egg salad at lunch today.
Tuna salad.
Egg salad today too.
Is it?
That's what I was told. Egg salad's supposed to be Tuesdays, but I put a hate letter into the suggestion box because they didn't have it the last 2 Tuesdays or 3 Tuesdays. I got a reply today. The general manager of Sodexo or something.
The man quit.
Yeah, I'm no longer welcome in the cafeteria. Apparently, I was belligerent in my.
I want to see this email. Like, how far can I take it?
How far can I take that? I replied with my most interesting man in the world picture.
Oh, dear Jesus.
So,
You're causing me mental stress with these pictures.
So anyways, he told me that they're going to start having egg salad on Tuesdays for those of you who've been missing the Tuesday egg salad.
Tuna salad.
Yeah, tuna salad's still on Fridays.
Like the only one that eats it.
No, and actually last Friday they didn't have tuna salad. Did they?
Yeah, they did.
Angry letters.
Oh, I don't eat lunch here on Fridays.
Staple of my Friday.
No, I'm with you. Because I was very upset when they didn't have egg salad on Tuesday. Or the previous Tuesday. Or the previous Tuesday. Or the previous Tuesday.
It's a crime.
Stuck in a loop. That's right.
All right.
Everybody run.
Break.
So, let's go back to our compiler here. And what we want to do is we want to deal with tokens in and of themselves. So we're going to create another method. Let's see. Let's call this
Oh no.
Yeah. I was all excited.
some extra S's in there in process statement.
Yes. But yes, I can.
That's fine.
Ah.
Okay. So what's process statement going to do? Process statement is going to start walking through our code.
Bro, you gonna fix that error?
What happened?
You didn't put any parentheses.
Parenthesis. Put some parenthesis. Okay.
Bro, you fix it.
You fix that. You understand me? Okay. So we have this method,
It's that boogie,
process expression. And let's go back down to our lexical analyzer. Shut up! What does our lexical analyzer currently do? It goes through and it grabs the next token. Correct? So getting a token is already handled by our methods. So if we come into process statement and we say, say string, we'll steal some of the code, per token is equal to this dot get token, while cur token it's not equal to null, we'll say system.out.println cur token, and then we'll say cur token is equal to the next token. So let's prove that this guy can go through all of our tokens, but we also want to now update our source code to a more Java-esque source code. So let's see, I think it was at the beginning of this chapter we had the little block structure example. We'll just use their example.
So more scrolling than I expected. Motion sickness.
Do you?
We can't even see what's up there.
There we go. Watch, I'm not going to be able to copy it. Okay. So we have that. Let's go out to our terminal. We got Michael's MacBook Pro today.
Oh, that's a much more normal name.
Possibly, although I don't think this says Michael anywhere in it, this machine.
Pretty sure Siri's just going.
So this is probably picking up another person named Michael. Except that's not a MacBook Pro 2. It's a wannabe. Okay, so it's. I was on my desktop. Where did I put my code?
I don't remember.
What did I call my code?
My first program
Yeah,
was
my
brother.
My first program, like,
It's not
Sign
there.
no, my first program, Dr. Silent, yeah.
Oh,
Oh no, it did pick up me this time.
Well, that doesn't look good at all.
Last time it picked up Pete.
Simon here, it's pretty better.
I agree.
I just got chip in mine speed.
Yeah. Okay, I forgot an I.
I totally hate you.
Okay, can I make plain text? Okay. I will say this is good enough. There we go. All right.
What the heck is break, J?
I feel like a J is supposed to be. I don't know.
Like some of the J's are supposed to be semicolons?
Yeah, that's how I feel.
Yeah, definitely.
Yeah, but definitely. All right.
It knows me.
Like A J equals X J. Expo.
Yeah, I don't think that J is supposed to be.
Which one?
And down.
There's
Oh, I was just going back to the beginning of the line.
Oh,
I process this way.
okay.
Wow. Alright, what kind of compiler is that?
Okay, do I plus L. Is that what they have? Yeah. I equals I plus 1.
What
Wow. What the heck is your...
the? You should never copy paste, bro.
Crap.
I don't know what's wrong with you.
You might as well just type it out yourself.
Yeah, I'm realizing that.
Here, we
While A of I is less than V.
Pretty good. Easy. I think 39. 39,
Month 7. 65. Well, whatever. Okay. 39. Oh, found it.
Where the whiles represent. Okay, they're out there. Then if I is greater or equal to J, then break. I wonder why it got some of the semicolons and not other ones.
So is that a lowercase x or?
So it should be a lowercase. X equals.
Everything else looks good from there.
So are we. Okay, does that pretty much match? Oh, I gotta kick this stuff down one line. That's what makes sure our spacing is the same. Just so we can prove our compiler ignores empty space or white space correctly. Okay. Legit? All right, so that's our code. Now we want to start walking through this guy, and we want to pick up each individual token. We want to prove that we're reading it. So process statement's going to get a token. As long as it didn't get the null token, we're going to print it out. So go back into driver. We're not going to do either of these things. Instead, we're just going to say source dot process statement. And let's see what we end up getting. Very special symbol. What the heck? What is this guy?
It's possible when it pasted in, it like picked it up as like something that kind of looked like one of the normal characters, but wasn't.
It's like a special kind of.
Well, at this point, anything's possible.
Just from the PDF. Or
Start
whatever.
over, type it up.
You should probably just maybe type like your own version.
There we go.
Be a lot quicker.
Well, I think we're good. We're not good. Totally not good. Whatever comes after the curly braces is completely unholy. Okay.
And
That's technically a Christian worldview. Hold on. Okay.
I guess you could have said worse words.
See? All right. Oh, hello. Hello, Joey.
Yes.
What?
oh, hello, wait.
Can't let you do that.
Hello. All right, let's see.
Oh, perfect. Maybe.
Okay, I think it's acceptable at what it should be. It's doing what it should be doing right now. Okay. So we're going to have to go and we're going to have to deal with the semicolons. We've looked at these before, but we need to finish dealing with them because now we have things that we're not. We dealt with them before in lexical analysis. Split them into two tokens. But now we need to deal with them at the time of tokenizing. That make sense? So as we're walking through this guy, get token is doing what? Started with a brand new token, empty. Keep reading until we read something that's not empty, not white space. As soon as we have that, we'll start tacking on characters. So So we'll read the first character, we'll read the next one. As long as the next one is not white space and it's not equal to -1, what will we do? Well, right now, if our code looks like this, is this guy white space? No, so we'll grab that. Then we get to the semicolon. Is this guy a white space? He's not. So we'll actually concatenate those two in there. So what we need to do is before we return something, we need to make sure that it doesn't have a trailing semicolon. Is that our only problem in our code right now? Is that some things have a trailing semicolon? Seemingly, right? What about this +1? Isn't this 3 tokens, 4 tokens? An I, a plus, a 1, a semicolon? How do we catch those? Right now I'm walking through this guy one character at a time. I'm reading in a character stream. Go ahead.
Other language reference?
Okay. So when I read in a character, before I just go ahead and tack it on to, before I go ahead and tack it onto my current token, I need to check to make sure this isn't part of my language. For instance, you will find in Java that you cannot have a plus sign in the middle of your variable name. Why is that? Plus signs mean something else, right? And if you have a plus sign in the middle of your variable name, then Java is going to look at it like you have two variable names that you're trying to either add together or concatenate, depending on whether or not they are mathable or strings. I've been using mathable a lot this semester. I've taken a liking to that word, that made-up word. I don't think mathable is actually a word. Kind of fondness. Okay, so how are we going to handle this in our parsing code? Go ahead.
We could, is there a way, like if we see int, float, or anything like that, we could add the following variable name to our language reference list? So like a temp.
Well, keep in mind that as of right now, we don't think about what features our language is going to have. The only problem we are solving right now is to split our code into tokens. That's the only problem we're solving. Otherwise, and there's two reasons for that, really. One reason is that the problem becomes too complex if you try to think ahead, because we'll never think about everything. And the other problem comes in that we don't know what our language will look like later on. So anything we do now to take that into account is going to be a bunch of special cases. Well, if it starts with an int, do this. Well, what if it's this new kind of expression that we add to the language 6 months down the line, and now we have to go back to our tokenizer and split that guy up differently? That make sense? So how would we implement this? What things do we want to skip? Are they individual characters? Are they individual strings? In Java, what kinds of symbols do you think, just start rattling them off, do you think are not allowed inside of variables?
Equal sign, plus sign,
Equal sign, plus sign, minus,
division slash e.
okay, times,
Modulus,
modulus,
Those are good options.
semicolon.
semicolon, it's true,
Caret.
also true. You know what the caret operator in Java is used for? Yeah, exclusive OR.
Like ampersand.
The ampersands, vertical bar-y thing.
Exclamation mark.
Exclamation mark.
We're good.
What about question marks?
Probably couldn't. I mean, I don't No, yes, ternary.
Is there any syntax you can do with with question marks?
Ternary operators. Use question mark.
Oh, the for inline if statements.
Yeah.
Okay, so question marks. So probably punctuation is out.
What's that?
So what about periods?
That'd be probably good to. Cause it also denotes methods. Like you call a method on a class with a period. So like this dot.
Yep. So that's a special symbol inside the language. Okay, so all punctuation, all operators, less thans, greater thans.
Brackets and parentheses.
Brackets and parentheses. Interesting question. How do we then handle situations like capturing less than or equal to as a single operator? As a single token.
They're right next to each other.
Well, but everything can be right next to each other. I don't disagree. The question is whenever you write software for something, you probably want to start off by start off with a goal of not creating a bunch of special cases. That isn't to say that you won't have some special cases. So what I'm asking is if we run into the token less than, we already just discussed that less than is not going to be part of it'll be part of a new token. So that is a delimiter for tokens, correct? But what about equal to?
Those kind of things, like you say, equal to, greater to, or equal to, with the two equal signs, would that always be in like a while loop or something like that?
Not necessarily. It could be anywhere you write a Boolean expression. You could say Boolean B is equal to 5 less or equal to 7.
Sometimes you do returns or something like that.
You just like make it a special case. It has to be preceded by something. I don't know what. Then it ends with something else, but like in between it can be two equals. Because I guess you can't have like say a space because it can be without spaces.
Mm-hmm.
But you can't say like one's a string because that's the order.
Let me ask you this. Right now, we are reading our file in one character at a time, correct?
Yeah.
Okay. And we build it right here with input. Down here, inside a process statement, I'm going to remove a bunch of this code just for right now. In fact, I'm going to remove all that code. Okay. I'm going to wrap my input inside of something called a Bufferedreader. So we'll import java.io, where that guy lives. And we'll say string line is equal to br.readline, while line not equal to null, system.out.println line is equal to br.readline. And this guy has a possible exception, unhandled IO exception. So we'll just, for clarity here, we'll just throw the exception there, and then back out here in main, we already throw an exception out there. So, all right, so we're throwing an IO exception here, so we're not going to even worry about it. All right, so process statement now should go through and read our code in one line at a time and spit it back out to the screen. That make sense? Joey?
Yes.
Does it make sense?
Yes.
What question did I ask?
No, I mean, does that make sense?
So what are you doing there?
Watching football highlights from a game a few years ago. It seems important.
It does it. Really?
Well, to me, but I mean, not in the grand scheme of
The
things.
grand scheme. Anybody else watching football highlights? Battery's dead.
I watched them all since
I
junior
would
class.
All right. Well, so pay close attention because you just earned a nice homework assignment. Okay. So we are reading things in one line at a time, and I'm printing out the entire line. I'm going to create a string tokenizer called ST. And after we read in a line, we're going to say ST is equal to a new string tokenizer line tokenized on, we're going to pick all of our possible tokens. So we're going to say less than, greater than, equal to, not, plus, minus, times, divide, modulus, ampersand, vertical bar, question mark, period, semicolon, comma. Let's see, what else? Caret. Do I have minus in there?
Yes.
Okay.
What hashtags?
Add plus minus.
This is okay for right now. I don't want to make your assignment too difficult.
I've never heard you say that.
All right. So we're going to create our string tokenizer. This guy is asking us to import java.util. All right. Now what we're going to do is we're going to say while st dot has more, well, has more elements is fine. I usually use has more tokens, but it doesn't matter. Has more tokens. We will system.out.println st dot next token.
Is there a difference between the two?
Between what two?
Has more things.
I don't think so.
Than where they have both.
I think has more elements, takes things as objects, has more tokens, treats them as strings. Okay, so this loop goes through, reads everything one line at a time, creates a new string tokenizer out of that line. It tokenizes on, oh, I also need to put a space in there.
Yeah.
Right? So it tokenizes things on spaces as well as all this other crap. And then we'll say st.has more tokens. We'll print out each individual token. And we'll do this for every line we read in our program. And what will we get? We'll get a whole bunch of tokens. Oh, that's right. We have these guys. Forgot about those guys. Right, Paul?
Yeah.
Okay. And we definitely don't want to have all those extra spaces in there. Correct? So when we print it out, we'll go ahead and trim it. That make sense? Very last thing is I'm going to use a different constructor for string tokenizer that takes a Boolean as a second parameter, and this guy will also return the operators. So it'll return the things that we delimited on. That make sense? All right. For homework, I'll give you this code as a starting point. I would wait till you say that here in a second.
What'd he say?
Joey's little football watching has incurred my wrath.
I'm going to backhand you. I'm going to watch more football while you backhand me. Good, you won't see it coming.
Oh man, wait till you see this assignment. This is gonna be just ridiculous.
This is when you don't poke the bear.
Worst parts of the Bible.
Bears, that's who I was watching lose.
Why does Angel like remember your old glasses from like 9 years ago?
All right, so homework number 4. Do Monday. Given the code below as a starting point,
I had a lot of texts this weekend asking questions about this.
parse an input file similar to, and let me go ahead and paste the code in here and I'll also give you an example input file.
Like this is supposed to be hard.
I don't know, last time we tried to copy and paste in there, it didn't work too well.
This is tripping.
Okay,
What the? Why is it blue?
I think it's fine. Why is it blue? Just cause.
Yeah, it's fine.
Question, Joseph.
All right.
That was the color of the bear.
So, shut up! Given the code below as a starting point, parse an input file similar to this. You may not use string tokenizer or split
Oh, man.
or any other built-in tokenizing method. You must write your own. It should split on all of those guys. Make sense? Really isn't that bad. All right. Questions, comments, concerns, bribes.
How much bacon? So, that's a
Your weight in bacon will save you.
It's done.
You still don't.
I will not be able to meet you at Sally's tomorrow.
No problem.
Got my cousin's daughter's birthday party to go to.
Why?
Okay.